This is a GCSE AQA chemistry question. It is from Trilogy paper 2019 and it is a foundation question. So I'm going to recommend that you pause on each section, have a go at it and then review. Let's get straight to it. Here is part A, parts B and C, part D, and finally part E. In total, a 9-mark question. So let's look at part A. We have got a multiple choice order of decreasing activity of the 4 metals provided. And we've got a diagram to help us to do this. So we're not simply having to remember the reactivity series, which is actually an important key skill. Now, the first thing I'm going to do is count the bubbles. If something effervesces more, that means it's more reactive. So I can see that I've got most bubbles here, least bubbles here, and then I've got second most in magnesium, third most in zinc. Now, because I can see magnesium is the most reactive, I can immediately disregard the first answer. So all of the other 3 start with calcium as most reactive. I want the one where magnesium is second most reactive, and we can see that the correct answer is therefore the bottom choice. Moving on to part B, 2 variables that must be kept constant here. Now there's more than 2 answers that you can give. We're essentially thinking about control variables. Remember, we change the independent variable. We measure the dependent variable as a result of our change to the independent variable, but we try to keep everything else the same. So we may have kept the mass of the metal the same, the surface area of the metal the same, the concentration or the volume of the acid the same, and potentially we could have kept the temperature of the acid the same as well. And what was the independent variable in this reaction? Remember, this is the one we're looking at. We can see same volume of acid. We've said same concentration of acid. We talked about the same mass of metal, but we're actually changing each time the type of metal that we're using. So that is the independent variable. Moving on to part D, predict the reactivity of beryllium compared with magnesium. Now they're both in group 2. Beryllium is higher in the periodic table. So beryllium is less reactive than magnesium. That's the first thing to say. Reactivity increases down group 2 as you go down the group. And that's exactly the same as group 1. Why? There's a greater attraction between the nucleus and the outer electron in beryllium. That's first of all because, and this is not for marks on this question, but it's because the outer electron is closer to the nucleus, so it's more attracted, and it's also subject to less shielding by inner electrons. And because of that, more energy is needed to remove the electron. On to part E to finish off. So we're told we've got 3.2 grams in 50 centimetre cubed. We want to know how many grams per decimetre cubed. Well, the first thing to do then is convert our volume into dm cubed. 50 cm cubed is 0.05 dm cubed. To work out grams per dm cubed, you will do grams divided by dm cubed. So 3.2 divided by 0.05. And that takes you to the answer of 64 grams per decimetre cubed. And that takes us to the end of the question.